I hope it's visible, right?
Yes, ma'am.
Okay. So today actually the class was on Wednesday, but there was a problem, so that's why I just shifted the class to today. So yeah. So today we'll talk about atomic and molecular physics GATE topic, and there will be 6 questions as usual. And we will talk about different questions on atomic and molecular physics from different GATE questions. I mean GATE previous year questions. So let's start. So this is the first question I have taken from GATE 2021 on atomic and molecular physics topic, and the question number is 14. So what is the question here? Among the term symbols 4-1, 2d 7/2, 3-1 and 2d 5/2, choose the options possible in the LS coupling notation. Okay. So and there are 4 options. I mean among these four options they are asking that which one is the correct LS coupling notation. Which one is giving the correct LS coupling notation. Okay, so we will talk one by one. First of all, I am just telling 4-1. 4-1. So LS coupling means what? First of all, from that notation, what I can tell, that the multiplicity is 2s plus 1. From this notation, what I can tell? From this notation, I can tell that the multiplicity is 2s plus 1, which is 4. This one is giving us our L value, which is 0, because you know that L is 0, 1, 2, 3, S, P, D, F and so on, right? So 4s1, 4 will give us the multiplicity, 2s plus 1. S, this S is giving the L value, L is 0. And this one is giving us J value. J is what? L plus S. I mean L plus S means the vector summation of L and S. Now we will check it is giving the correct configuration for LS coupling or not. 4s1. So from that what I told you, that 2s plus 1 is 4. That means the multiplicity is 4. So from that I can have the value of S. S is the spin quantum number. So from that I can have the S value is 3/2, because it is 4 minus 1 divided by 2. So that means 3/2. So I get S equals to 3/2. And from this notation, this S notation, I can have the value of L, which is 0. Right? So L is 0, S is 3/2. Now you can see that if L is 0 and S is 3/2, then what will be the value of J here? I think I am not audible. Okay, fine. So from that case, J will be what? J will be mod of L minus S to L plus S in steps of 1. In steps of 1. That is as usual, right? So for that case, if our L is 0 and S is 3/2, then what will be the value of J here? J will be only 3/2, because you can see that 3/2 minus 0 or 3/2 plus 0, it is giving the same answer. So that means J will be 3/2. Now you can see that the configuration was that one. So here our J is giving us 1. So that means it is not giving the LS coupling configuration. Okay. So for knowing that which one is giving the LS coupling configuration, we have to calculate L value, S value from these notations, and then we have to calculate J value. If this J value is matching with this J, whatever it is giving here, then we can say that this is giving our correct possible LS coupling notation. Okay. So now we have seen from the first one that 4s1 is not giving the possible LS coupling notation, because for 4s1 our J is giving as 3/2, and here in that case it is giving as 1. That means 4s1, this notation is not possible for LS coupling notation. Now coming to second one, 2d 7 by 2. 2d 7 by 2. So what will be here? You can see that similarly 2s plus 1 is 2. Now 2s will be 1. So s will be 1 by 2. Now coming to d. D is giving what? L will be 2 because H, P, D, F 0, 1, 2, 3. So that means L will be 2 here. Now coming to J value. J will be what? 2 minus half, 2 plus half. Now 2 minus half will be what? 4 minus 1, that means 3 by 2. And 2 plus half is what? 5 by 2. In steps of 1. So that means J can have the value 3 by 2 or 5 by 2. Now you can see the notation that here our J is giving us 7 by 2. So that means this notation is also not possible for LS coupling notation. Okay. Now coming to the third option. 3S1. 3S1. For here I am just going to write here quickly that 2s plus 1 equals to 3. Then 2s will be 2 and h will be 1. And from this notation L can be written as 0. Then what will be the value of J? J will be 1 minus 0 to 1 plus 0. That is nothing but 1. Now you can see that this one, our J is coming as 1, and here also in that notation it is giving as 1. So that means 3S1, that is possible for LS coupling notation. Okay, so that is possible for LS coupling notation because the value whatever we are getting of J from L plus S or L minus S, that is also given here in that notation as J. Okay, now coming to D option. These questions are MSW, like multiple selection questions. So that means one or more than one option can be the correct one. So we have to check each and every possible combination. Now coming to the fourth one, 2D 5 by 2. Okay. 2D 5 by 2. Now here you can see 2s plus 1 equals to 2. S will be 2 minus half. Now D. D means L is 2. If L is 2, that means our J will be what? 2 minus half to 2 plus half. So what will be the value here? 3 by 2 and 5 by 2. Now you can see that this 5 by 2 is given here as J. Now we can tell 2D 5 by 2, this is possible for LS coupling notation. Okay. So how many options we are getting as LS coupling notation? This one and this one. So the correct one will be C and D. Okay. If you have any doubt, you can ask me, or otherwise we can go to the next question. See, basically they are asking that which one is the possible notation for the LS coupling notation. So here we will check that what will be the value of J from that L and S coupling configuration and what is giving as J here. If these two J are equal, then only we can tell that this possible configuration will give the LS coupling notation. Okay. I have already discussed the first question. The first question we were talking about on atomic and molecular physics GATE topic, and the question I have taken from GATE 2021 question paper, and the question number was 14. So I have already discussed that one. The correct answer will be C as well as D. As these questions are MSQ question, so that means more than one question, more than one option can be the correct one. So here we have checked that C as well as D, these two are the correct option for this question. And the question is saying that among the term symbols, choose the options possible in the Ellis coupling notation. Okay. Okay, so now we will go to the next question. Yes, so next question also I have taken from GATE 2021 question paper, and the question number is 23. So what is the question here? The transition line as shown in the figure arises between 2d3/2 and 2p half states without any external magnetic field. The number of lines that will appear in the presence of a weak magnetic field in integer is what? So this question is nothing but the Zeeman effect question. Okay, that sodium light Zeeman effect question, we have already read these things, that what will be the condition when, and what will be the consequence of when we are applying one weak magnetic field in the spectra is getting splitted, and all these things we have already learned. So this is nothing but the weak Zeeman effect consequences they are asking about. Okay, so in that question they are asking is what? They are asking that from this 2d3/2 to 2p half, this state, I mean from this state to this state there is only one line, I mean there is only one spectral line is coming when there will be no external magnetic field. But if there is one weak magnetic field, then what will be the value of, I mean how many lines will appear in the presence of weak magnetic field? That is the thing. So what we will do? We will simply do whatever we are doing in that Zeeman effect theory part also. We will do the same thing here. 2d3/2 2p half, right? So 2d3/2 2p half. Now you can see here, when there was no magnetic field, then there was only J here. Now right now we have the splitting here due to the magnetic field, and the splitting will be like minus half and half. The mj value will split out, right? Now for the 3/2 case, if it is 3/2, when there was no magnetic field, at that time there was only one line for the 3/2 case. But now in the presence of magnetic field, we have how many mj we have? We have 4 mj. Minus 3/2 minus half plus half and plus 3/2. So we have 4 splitting due to the weak magnetic field. Now due to the Zeeman effect, there is a selection rule. The selection rule is what? Delta L equals to plus minus 1, and delta mj can be written as 0 and plus minus 1. So obviously you can see here that L is obviously here plus minus 1, right? Because here L is 1 and here L is 2. So that means the delta L is plus minus 1. That means only from here to here all the possible splitting can be possible. All the possible lines will be there, allowed. Now due to the condition delta mj equals to 0 and plus minus 1, how many lines are getting, we have to check. So from here you can see that minus 3/2 is there. So if I am talking about minus 3/2, so from minus 3/2 only minus half can be a line, because minus 3/2 minus of minus half, it is giving us minus 1, right? Now from here to here there will be no line, because here minus 3/2 minus half, then what will be the value here? Minus 2. But minus 2 will not be the correct one, because the selection rule is saying that delta mj can have the value 0 and plus minus 1. Fine. Now coming to minus half. From minus half to minus half there will be one line, because minus 1 minus of is giving us 1. From minus half to plus half. Okay, this from here to here it is giving 0, and from here to here it is giving 1. So that is possible. Now coming to half. From half to half it is also possible, because it is giving 0. From half to minus half it is also possible, because it is giving 1. Now from 3/2. From 3/2 there will be 1 half, because it is giving delta m j as 1. So you can see here 1, 2, 3, 4, 5, 6. There are maximum 6 possible lines we are getting when we are applying one weak magnetic field in for that transition line. Okay, so that means our correct answer will be 6. The transition line as shown in the figure arises between 2d 3/2 and 2p half states without any external magnetic field, but the number of lines that will appear in the presence of a weak magnetic field in integer is 6. So it is nothing but the sodium D lines. You know that there is sodium D lines, D1 and D2 lines. There will be 6 lines and there will be 4 lines for D1 and for D2. So as a whole there will be 10 splitting lines in presence of Zeeman effect. So it is nothing but the application of the Zeeman effect, whatever it is given in question number 23. Okay. So I think it's understandable by all of you because it's very simple one. Okay, so we will go to the next question. Okay, so next question I have taken from GATE 2019 question paper, and obviously the topic is atomic and molecular physics, and the question number is 44. Okay, so what is the question here? You can see here the ground state electronic configuration of the rare earth ion. Rare earth ion is what? Nd 3+, and the electronic configuration it is already given here. Ground state electronic configuration it is given that Pd 4f3 5h2 5p6. Assuming LS coupling, the Landesi factor of this ion is 8/11. The effective magnetic moment in units of Bohr magneton mu b rounded off to 2 decimal places is what? They are asking this one. They are asking basically what will be the magnetic moment of this ground state electronic configuration of Nd3+. There is something. Okay. So what will be the value of magnetic moment, effective magnetic moment for that case? Okay. So what we will do? We will quickly write the electronic configuration whatever it is given here. For Nd3+, what is giving here? Pd, then 4f3, then 5h2 5p6, 5h2 5p6, right? Now what we can understand from this configuration? First of all, you can see here the outermost cell is 5s and 5p, but 5s is fully allowed. It is full. It is not. Fully filled. And for this case, this is also fully filled. You can see here, 6 electrons at most can be put here for the p orbital, as well as for s orbital 2 electrons can be put here. But the main unfilled thing is here. So what is there? You can see here. For F, there will be 7 column. Like 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So among these 7, only 3 are filled. So that means how it will fill? Obviously due to the Hund's rule, 1, 2, 3, like that. So if it is okay, so F means our L is 3, and you know that. -3, -2, -1, 0, 1, 2, 3. It is like that. So our L is 3. From that notation I can get. Okay. Now also I can get one thing, that it is already given here that the Landesi factor of this ion is 8/11. G is 8/11. Okay. So our G is 8/11 and our L is 3 here, right? So if L is 3 here, and okay, so now we have to check from here that what is the value of H. You can see here that there are 3 unpaired electrons present. So if 3 unpaired electrons are present, that means each and every electron has the speed half, so that means the total S will be 3 by 2. Now what will be the value of J here? So J will be from L plus S to L minus S, something, in steps of 1. So naturally I can write here 3 plus 3 by 2, so which is nothing but 9 by 2. So our J is 9 by 2, G Landesi factor is 8 by 11. So from that electronic configuration, I can get the value of L, I can get the value of J. From these two, I can get the value of A. From L and S, I can get the value of J also. Now, if I got the value of J here, which is 9 by 2, and I also got the value of G here, what is 8 by 11, I can quickly write the magnetic field, what is there? Effective magnetic moment. Effective magnetic moment will be what? Effective magnetic moment will be G into mu B into root over J plus 1. Now simply we are getting J, we already have the value of J and G, so we will just put these values 8 by 11, and yes, they are asking that you have to write the answer in the unit of mu B, so that means our mu B will be in rightmost. And now 9 by 2 into 9 by 2 plus 1. This is the case. Now you can see here 8 by 11, 9 by 2, 11 by 2, mu B. Now if I just write here a little bit, then it will be root over, you can see here 11 and 9, so that means 11 and there is 3, and here it will be 2 because 2 and 2 was there. So 2, 4, so 4 by root over 11 into 3, so that means 12 by root over 11. But they are asking, I think, yes, they are asking the value of magnetic moment, which is rounded off 2 decimal places. So if I just calculate that one a little bit, 12 by root over 11, 12 by root over 11, it will give us 3.618. So 3.618 mu B. But they are asking that 2 decimal places you have to round it off. That means 3.62 mu B. That is the answer. So to have the answer, what I have done, I have just calculated, the G is already given here. I have just calculated only the J value. And how I got the J value? I got the J value from the combination of L and S. And how I got the L and S value? I got that L and S value from the electronic configuration of Nd3+, which is PD 4F3 5S2 5P6. Now 5S2 and 5P6 are fully filled, so there is no contribution from these two. There is only one thing which is unfilled, and the main contribution of J will come from this unfilled state. So that's why I have written like that. Okay, so from by knowing the J value, I just got the value of mu, which is G mu B root over J plus 1. Okay, and if I do the simple calculation, then it is giving us 3.62 mu. So this is the required magnetic moment for this electronic configuration. Okay, sure. I think I can go to the next question. Today I am talking about 6 questions on the same topic, atomic and molecular physics. Okay, so this question I have taken from GATE 2019 question paper, and the question number is, question number is 48. Basically, I can tell you that this question, whatever I am right now going to tell you, that is not exactly from atomic and molecular physics, but it is something related to this one, so that's why I just put it here. But basically it is coming most probably it will come from the nuclear physics, but it's fine, like physics is everywhere. So what is the question here? A radioactive element X has a half-life of 30 hours. Okay, it decays via alpha, beta and gamma emissions with the branching ratio for beta decay being 0.75. The partial half-life for beta decay in unit of hours is what? This is the question. First of all, I just want to tell you, this is X, it is a radioactive element, and this X is going to decay via alpha, beta, gamma. All type of radiations can come from X. And the half-life of X is T half of X, let me write here like that, X is 30 hours. In that question they are telling that the branching ratio for beta decay is 0.75, then what will be the partial half-life for beta decay? Okay. So now what is branching ratio? The branching ratio can be written as like decay mode of beta, because they are asking about only beta decay, right? Beta decay branching ratio. Decay mode of all possible particles. Like I am just going to write here a very layman language. So decay mode of beta divided by decay mode of all possible particles. All possible particles means it can be alpha, it can be beta, it can be gamma. But now we already know that the decay is proportional to 1 by lifetime, like half-life, right? So if I just put this condition here, then I can write here branching ratio of beta can be written as 1 by T half of beta into 1 by T half of X. Why? 1 by T half of beta, this is nothing but the decay, this is proportional to the decay of beta. This whole, not this whole, this is the decay, this is proportional to the decay of X, the decay of X to alpha plus beta plus gamma, and this is the decay of X to only beta. So you can see that we are just going to write here the branching ratio, which is nothing but the ratio of these two decays, the decay of X to beta divided by decay of X to alpha, beta and gamma. And in terms of time period, like half-life, I can write like that, 1 by T half of beta into 1 over 1 by T half of X. Now if I just simplify that one a little bit, this is T half of beta and this is T half of X, right? Now in that question it is given that 0.75 is the branching ratio for beta. Now in terms of T half, what I can write? T half of X divided by T half of beta. Now what will be the value of T half of beta? T half of X divided by 0.75. Now you can see that the T half of X is already given here, which is 30 hours. So I am just going to write here 30 divided by 75. What will be the value of this one? Let me write here. 30 divided by 0.75. It is giving us 40. So 40 hours. So from that question I can have the answer that T half of beta is 40 hours, right? A radioactive element X has a lifetime of 30 hours. It decays by alpha, beta and gamma emissions with the branching ratio for beta decay being 0.75. The partial half-life for beta decay in unit of hours is 40. This is the answer of that question. Okay. Okay. So now we will go to the next question. Here. The next question I have taken from GATE 2022 question paper, and the question is question number 14. Now see the question here. An excited state of calcium atom is Mg3p5 4s2 3d1. The spectroscopic terms corresponding to the total orbital angular momentum are S, P and D, P, D and F, P and D, S and P. There are 4 options. So what is the question basically? The question is telling that there is an excited state of calcium atom and the excited state is already given here. So what will be the spectroscopic terms corresponding to the total orbital angular momentum? Now first of all I am just going to write here the excited state configuration of calcium, whatever it is given here. Magnesium 3p5, then 4s2 3d1, 4s2 3d1. Now you can see here, okay, so you can see here for 3p5 what will be the case here? 1, 2, 3. This one, this one, this one, this one, but this one is left unpaired because 3p5 is there. Now if you see the S case, for S there is fully filled. Now coming to D. D will be what? 5 cell will be there, 1, 2, 3, 1, 2, 3, 4, 5. Among these 5 only 1 will be filled. And the field is like not fully filled, it is halfly filled. I mean only 1 is there. So that means for the contribution of the L, that means total orbital angular momentum, this one will not this one will not work. Which one will work? This one will work and this one will work. How? Because this one is fully filled, so it will give the total orbital angular momentum for this case as 0. But it will not give as 0, this is also not giving as 0. So in that question they are asking that what will be the total orbital angular momentum spectroscopic terms. So we have to check that what will be the possible value of L in that case. Now see, our L has the contribution from P as well as from D. So if we are talking about P, so P means what? Our L1 is 1. From D, L2 is 2. So that means our total L will be mod of L1 minus L2 to L1 plus L2 in steps of 1. Right? Our L1 is 1, L2 is 2. L2 is 2. So what will be the value of L here? The L will be 2 minus 1 to 2 plus 1. So 2 minus 1 is what? 1, and it is 3. So in between 1 and 3, which one will be there? 2, because in steps of 1 we are calculating. So that means our total orbital angular momentum can have the value 1, 2 and 3. Now what will be the spectroscopic notation for these 3 values of L? 0, 1, 2, 3 like that. What will be the L value? S, P, D, F like that. So 1, 2, 3, that means S, P and D spectroscopic notation will be there. So the answer will be in that question, L have the value, L have the spectroscopic notation as P, D and F. Now you can see that which one is the correct one. P, D and F. These 3 are the spectroscopic terms corresponding to the total orbital angular momentum of excited state of calcium atom, which is Mg3p5 4s2 3d1. Okay. Now let's say I am talking about one spectroscopic notation where only let's say 3d2 is there. So obviously there is nothing we have to do as L1 plus L2 or L1 minus L2, something like that. because here only one is there which is unfilled. So for that case our L will be 2 only, simply. But as in that case P is also unfilled, D is also unfilled. I mean not unfilled, not fully filled. So that means we have to take these two combinations in our total orbital angular configuration. So L can have the mod of L1 minus L2 to L1 plus L2 value. Okay. Okay, so I think it's understandable. Now coming to the next question. I think this is the last question for this topic. So this we have taken from GATE 2022 question paper, and the question number is 32. So what is the question here? In a solid, the Raman line observed at 300 centimeter inverse has intensity of Stokes line 4 times that of the anti-Stokes line. The temperature of the sample is how much Kelvin? And they are telling that you have to do the answer by rounded off to nearest integer. And it is also given that 1 centimeter inverse is equals to 1.44 Kelvin. Okay. So this is the question, and how to solve that question. So first of all, the question is telling in the Raman lines of the Raman line is observed at 300 centimeter inverse. So what is 300 centimeter inverse basically? 300 centimeter inverse is nothing but the nu bar, not nu. Okay. Okay, and one more thing was given here, the intensity of the Stokes line. Let us write here IS as intensity of Stokes line. Let us write like that. And IAS, let us write like that, intensity of anti-Stokes line. So IAS is intensity of anti-Stokes lines and IS is intensity of Stokes line. From that question it is given that the intensity of Stokes line has 4 times that of the intensity of anti-Stokes line. That means IS is 4 into IAS. Now if I do that one, then the value will be 4. Right? Now we have to know that what is the relation between intensity and temperature, because they are asking the temperature of the sample. So obviously there should be some relation between the temperature and the intensity of the Stokes and anti-Stokes lines. Right? So if I write the relation here, the relation will be like, okay, I am just going to write here the full expression IS divided by IAS. That is equal to nu 0 tilde minus nu m tilde. I am going to write tell the what is these things. Nu 0 tilde plus nu m tilde whole to the power 4 e to the power h nu m tilde c divided by kBT. So I think all of you understand that one. What is this one? This is nu 0 is the undeflected one, I mean like a relay line, and this one is the nu m, I mean the separation. So the separation is observed at, in that question it is given that the separation is observed at 300 centimeter inverse. And now you can see here that whatever the thing is there, this thing as a constant, right? So I can write here IAS is proportional to e to the power h nu m tilde c divided by kBT. That I can write. So from that case I can write here ln IS IAS is proportional to, you can see here, H nu m C by kBt. H nu m C by kBt. Now I have already told that what is the value of this one. Yes, this one will have the value ln 4. So like H nu m tilde C divided by kBt is equals to ln 4. Now if I calculate a little bit more, we got the value of lm tilde, which is 300 centimeter inverse. Now we also have the value of kb, which is 1.38 into 10 to the power minus 23 joule per Kelvin. Now I have also the value of H, I have the value of C. If I just put these values, then I can get the value of T. So what will be the value of T? T will be H nu m C divided by kb into ln 4. Now one thing we have to check very carefully, the unit. See here the unit. T is H nu m tilde C by kb into ln 4. Now you can see H is what? H is 6.626 into 10 to the power minus 34 into, so this is in terms of joule into second. Now nu m tilde it is giving as 300 centimeter inverse, but we have to convert that one in meter inverse because all the rest of the things are in SI units. So centimeter inverse is the giving as CGS unit. So that means if I am converting that one to SI unit, then it will be like this one. So if I just going to write here, see here that nu m tilde is given. Now H, H H is 6.626 into 10 to the power minus 34 joule into second. Now C is 3 into 10 to the power 8 meter per second, and then K is 1.38 into 10 to the power minus 23 joule per Kelvin. So if I put all these things here, then the answer will be in Kelvin only. So what will be the value here? 6.626 into 10 to the power minus 34 into 300 into 100 into 3 into 10 to the power 8 divided by 1.38 into 10 to the power minus 23 into ln 4. So let us calculate that one. First of all, I am just going to write here the coefficients only. 6.626 into 300 into 100 into 3, right, divided by 1.38 into ln 4. Okay, so this is 311716. 311716 into 10 to the power, you can see here, minus 34 plus 8 minus 23. So minus 34 plus 20 plus 8 minus 23. So what will be the value of this one? it will give as 34, 23. So it will give sorry, this will be plus. This will be plus. So 34 minus 34 plus 31. So that will give us only 10 to the power minus 3. So that means our T will be 311,716 into 10 to the power minus 3 Kelvin, which is nothing but 311.716 Kelvin. So the answer will be 311.7 Kelvin, or you can say like that 312 Kelvin. I think they are asking round off to the nearest integer. So that means 312 Kelvin. This one will be the answer for the question. Yes. Sorry? New M. New yeah. So new, see, basically the new M is the frequency of the, at which the Raman line is observed. But here you can see that it is given as the line, the new, see, H new was energy, energy, but we are talking about new bar, because in the new it is given as a centimeter inverse unit. So that means we are talking about new bar, and new bar is what? New bar is nothing but like, if I write here C energy equals to H new, which is nothing but HC new bar. So new is nothing but C into new bar. So as the answer is giving, the data is giving in terms of centimeter inverse or meter inverse, which is new bar. So that's why we have just we have changed the value of new to new bar by the relation new equals to C into new bar. Basically, I am writing here new tilde, but it is exactly the same as new bar. Sorry. So I am writing here new bar, new tilde, which is nothing but new tilde. You can see here that that's why we are writing here H new M tilde C by KBT. So this is the case that new new M is related to new M bar by the relation new equals to C into new bar. New M bar. New C into new M bar. My laptop is getting hang, so okay.